Hello students, today we're going to be showing further that triangles are congruent, and we're going to see that we don't necessarily need to show every single piece like we did today in class. So let's get started and discuss it. Please make sure you're taking notes, and at the end make sure you do the check that is found on underneath the video. So let's take a look at an essential situation here. A building contractor has just assembled two massive triangle trusses that will support the roof of a recreation hall. Before the crane hoists them into place, the contractor wants to verify that the two triangular trusses are identical. According to the definition of congruent polygons, which we discussed earlier today, if the three sides and three angles of one triangle are congruent to three sides and three angles of another, then the two triangles are congruent. So based upon what we did earlier today, we need to actually go through and measure all three sides and all three angles and verify. So our real essential question here is that necessary? Do we actually need to measure all 6 parts? And the answer to that is no. We have a couple different type of triangle congruence postulates and theorems and so on and so forth. Our first one is side-side congruence postulate. And what this says is if we have 3 sides of one triangle and 3 sides of another triangle, and they're congruent to each other, then we can go ahead and just conclude that those triangles are congruent. So we don't need to know anything about the angles in this situation. We just need to know about the 3 sides. If you were to take 3 sides of anything or of the same size and put them together, say we use straws or something like that, and you were to tie them all together, we would not be able to form more than one triangle through that. So again, if we have 3 sides of one triangle congruent to 3 sides of another triangle, then those 2 triangles are congruent. So let's take a look at a couple of examples. We want to decide whether the congruent statement is true and to explain our reasoning. So in the first one on the left there, we want to make sure that DFG is congruent to HJK. And remember, it's not good enough to just see here's one side, here's another side, and here's a third side. We actually need to make sure we're paying attention because order does matter here, as we discussed in class today. So if you take a look, we want to first compare DF with HJ. So DF and HJ, those guys have 2 tick marks, so yes, they're congruent, that's good. Then we want to compare FG with JK, which are these 2 here. They each have 3 tick marks, they're congruent to each other. And then finally DG and HK, they also have the 1 tick mark. So we know that all 3 sides are congruent to 3 sides from the triangle, and it's in the correct order in your triangle congruence statement. So by side, they are congruent. Now we can abbreviate side, as you see by SSS, just so you know. Let's take a look at the middle one there. So once again, we're going to compare ABC with CDA, these 2 triangles here. So let's first start with going one at a time. Let's see, we have here AB, we're going to compare it to CD, and you can see right off the bat, AB is not the same length as CD. So in this situation, you can say no, because one of the side lengths is not equal to the side length of the other one, so we don't have 3 congruent side lengths for a triangle. So that is not going to be possible for us. Alright, taking a look at the last one here, again, based upon the tick marks, you see 3 sides congruent to each other. That's great. So let's take a look at the statement. The statement here. So the first one is QP. We're going to compare it to RT. So I have QP here, and I'm comparing to RT here, and you can see that that is not congruent to each other. This one has 2 markings and that one only has 1. So the answer to this is, while those 2 triangles are actually congruent to each other, the statement is indicating that segment QP is congruent to segment RT, and that's a false statement. So in all actuality, it should read QPT is congruent to RST, because again, we need QP to be with RS and so on and so forth. So yes, these 2 triangles are congruent, but the statement was incorrect. This is what it should actually read. So another type of example we can have is if I give you the value of a couple of vertices and we want to check that those triangles are congruent. So in this case, we've got one triangle JKL, that's this one here on the left, which there have already been plotted for you, and then RST, same thing here. So what we want to do is determine if they are congruent. As of right now, our only methods are to either check all the angles and all the side lengths, or we can use the congruence postulate we just discussed and just check all 3 sides. So that's what I'm going to go through first. So the first one I'm going to look at is JK and RS. So as you can see, if I were to count, this is 1, 2, 3. Same thing with RS, it goes down 1, 2, 3. Then I'm going to compare JL with RT. So these are the up and down one here. So if I count that, it goes up 1, 2, 3, 4, 5, 6. And if you count an RT, you get the same amount. And then we would need to check one more side. So you can use the Pythagorean theorem, or you can use the distance formula, whichever you care to use. But what we end up here is the square root of 45 for both of them. Now you can go ahead and put them in decimal form, or you can simplify it. It doesn't really matter. Regardless, they're the same number underneath the same square root, so it's going to be the same length. So as you can see, we've got three sides here that are going to be the exact same length. So by side, 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 or by SSS, we know that triangle JKL is congruent to triangle RST. So one thing I want you to kind of think about is looking at these two benches that these men are sitting on in the football game. And why do you think that the bench with the diagonal support on the left is more stable, sorry about that, is more stable than the one without the diagonal? Why can the one without the diagonal collapse? So that's the one question I want you to think about. And I want you to answer this on the survey. So once again, if you have any questions, please bring them to class tomorrow. We're going to do some practice with this as well as just regular congruence. And then from there, we will move on to the next topic, but let's focus on side, side, side for right now. All right, see you tomorrow.